I'm Anil Kumar. Welcome to my series on multiple choice questions. Here is an excellent example based on sequences and series. The question here is, solve for x. The sequence given to you is x minus 1 over x plus x minus 2 over x plus x minus 3 over x plus so on till 1 over x equals to 4. So the sum of the series is 4. You need to find the value of x. X is given to you as greater than 0. You can always pause the video, answer the question, and then look into my suggestions. Now looking into this, we can take 1 over x common. So let this be our first step, which is kind of straightforward. So we get x minus 1 plus x minus 2 plus x minus 3 plus so on, and the last term here is 1. And all this should be equal to 4. Now the question here is, how many terms are there? So we have, this is our first term, second term, third term. Now which is the nth term? We could find this by replacing 1 with something which is similar to x minus something, right? So we'll know the number of terms. So we could, since we don't have x here, we can say x minus x, which is 0, right? So plus 1, that gives you the idea, right? So that means I could write this as x minus 1, right? So that gives me x minus 1 terms in the given series, right? So we could rewrite this as 1 over x times x minus 1 plus x minus 2 plus x minus 3 plus so on, and last term being x minus 1, and that should be equal to 4. So clearly now we have x minus 1 terms, right? So we have the number of terms are x minus 1. Okay, how does that help? Well, now we can add the number of x's. So we have 1 over x times, since we have x minus terms, there are so many x's. When you add them, you get x times x minus 1 plus, or since all these terms are negative, let me take negative here, and we get this series, which is 1 plus 2 plus 3 plus so on till x minus 1, right? And that should be equal to 4. So we have a series here which has x minus 1 terms, and here we have one term which is x times x minus 1, right? So this is all x. Yeah. Okay. Now what is the sum of this series? It is sum of natural numbers, right? You know, sum of natural numbers where n is equal to from 1 to n is given to you as n times n plus 1 divided by 2. So you could use this formula to move forward and find the sum of this particular series. So what we get here is 1 over x times x minus 1 minus all this is n, the number of terms, times n plus 1. So the number of terms are x minus 1, right? So we have x minus 1 times number of terms plus 1, which is x, right? X minus 1 plus 1 you could write, divided by 2. So that is the sum of all this. This should be equal to 4. Perfect. So what we get here is 1 over x times, now here we could simplify this. We can take x minus 1 over 2 common. Here it is x, right? Let me rewrite this also. So what we get here is x, this term is also x, and this is x minus 1, right? So x minus 1 minus x minus 1 times x over 2, right? Equals to 4. So that is, when you take this as common, you get 1 over x times x minus 1 over 2, perfect, equals to 4. Now from here you can cancel x and x and solve for x. So that gives you the solution. So from here we can cross multiply. So we get x minus 1 equals to 4 times 2, which is 8, and x is equals to 8 plus 1, which is 9, right? So the option C is the right option. So that is how you could actually solve such a question. Now, this kind of strategy you could apply to many different questions. Let me give you one which is very similar to this. Now, we could have these terms as squares, correct? And then also we can apply the same strategy. The only thing will change is this particular formula. So you could have a series like x minus 1 over x plus x minus 2 square over x plus x minus 3 square over x plus so on till 1 over x equals to, let's say, 3, right? And find x. So let this be the question for you. So this is a practice question for you. So I hope that will help you to practice similar kinds of questions and understand this particular strategy. I hope that helps. Feel free to write your comments and share your views. If you really like and subscribe to my videos, that'd be great. Thanks for watching and all the best.